So looking at now ANOVA testing and verifying the requirements. Again, we have these requirements we talked about. It's hard to verify these other than given from the samples that they are conducted from a simple random sample. And so you have that. The samples are independent of each other. Again, we just assume that's true. The ones that we can test are the populations normally distributed. Populations have the same variance, where each group that we're comparing has a population variance of your standard deviation squared, of course. So we can look at that. And that's what we're going to do in this short video here. And so again, here are the requirements of testing. If it's normal, I'm going to show you that test now using StatCrunch. There's also a rule of thumb we use to determine the requirement of equal population variances for a one-way ANOVA test. And here's the rule here. A one-way ANOVA procedures may be used if the largest standard deviation from your samples is no more than twice the smallest standard deviation. Remember, variances and standard deviations are pretty much related to each other, right? Because one is the square root of the other, or 1 squared of the other. And so that's the rule of thumb we would use. Additionally, here's an example of verifying them. Again, we're going to assume the data was from a simple random sample. They're independent, right? And so the first thing we want to do is check to see, using this here, if the correlation coefficients for our data are relatively close to 1. If we have to, we also could look at the critical value table. But let's take a look at how we can quickly do that. I've entered this data into StatCrunch already. And so with that in mind, I'll get there. With that in mind, there it is. Sorry. There's the data in StatCrunch. What we do is you're going to go to Graph QQ plot, and those instructions are up there. Select all of these values. We're comparing these values together, and then make sure you click Add the Correlation Statistics, and then Compute. And you do that, you'll get the correlation statistic up here, 0.986, 0.92 for those 4 variables there. And so you can see those are all very close to 1. I had them here in green, highlighted now. And those values came from when I ran this QQ plot, graph QQ plot, and then I was looking for the statistic, and it's close to near 1. If that's the case, then we're meeting the requirements that when we wanted to test if these means are the same, right? If they're all equal to each other, we need to verify that the graphs are normally distributed, and so that's what we would do here. Then again, you can take a look at the notes here. You also can see, if we wanted to compare the standard deviations, you'll see this example there. The smallest, here's the data from it. You could use summary statistics to get it. I've already calculated here. So you can see that 2 times the smallest is greater than the largest one, or the largest one is no more than twice the smallest. So we have those verifications are now met. And so that's how we would check the requirements before running an ANOVA test. So just keep that in mind. You need to do those 2 things there.